Solenoids. Solenoid is just a fancy name for many turns of wire in a loop. So this is what they look like. The copper wire is insulated with like a plastic film, and it goes round and round and round and round and round and round. So they're really useful. They're used a lot in electrical appliances or devices, things like your washing machine. Anything which has a motor in it will have solenoids in it. So it's a long straight coil of wire used to generate a controlled and almost uniform magnetic field. Because when you see the diagram here, this is a diagram of what that would look like if you were to cut it lengthways. So the coils of wire are going into the page and around and out of the page. And down the center of it, see how the field lines are spaced really evenly here? So that's a pretty uniform magnetic field in the center there. The right hand, you can use a right hand rule again for these, only this time your fingers are going to curl around. So your fingers are going to curl around in the direction that the current is going through the wires, and your thumb will tell you which way north is. Right, so if we look at this one, the current's going into the page on the top side and out of the page on the bottom. So it is in fact going in and around and out. So my thumb is going to tell me north is this way to the left. So that works out all right. There's only two super simple rules. I suppose it makes sense. The number of turns is not as important as the number of turns per meter, how densely packed those turns are. So you want the number of turns per meter, which is the number of turns divided by the length of the solenoid. So that 2,400 turns per meter is this is example 7.3. And then the magnetic field strength is going to be that permittivity constant, which was 4 pi by 10 to the negative 7. Remember, in the last example, we cancelled that out with a 2 pi. But 4 pi by 10 to the negative 7. And if you put 4 pi by 10 to the negative 7 in your calculator, you get 1.26 by 10 to the negative 6. That's a constant. That's its value. That's the number of turns per meter, and that was the current that was going through it. So you're going to generate a magnetic field 0.0091 Teslas. So that's pretty simple. And it says you'd also want to know which way the field is going. So in our example here, the conventional current goes from positive to negative. So it's coming down the front of the solenoid and around the back. So it's coming down the front and around the back. So you'll end up twisting your hand like this with your fingers down the front and coming up around the back. And your thumb is pointing to the right. So the right is the direction of north from this solenoid. And yes, that's what they've got as well. So that's good. I think those are pretty simple. I'm not going to work those out in this learning bit here. You should be right with those.